Okay, good morning or afternoon, Honors Pre-Calc. This is going to be a lesson on section 4.1, day 2, and we're going to focus more on arc lengths and radius, and we're going to get into linear speed and angular speed problems. And then when you're done with this video, you can start the homework. The first formula we're going to be looking at is this arc length formula. Arc length equals the radius times that central angle, theta. But the main thing is that theta must be measured in radians in order for this formula to work. Now, back in geometry, you learned a different formula for arc length, and it was a little bit more complicated looking. So this formula is definitely simpler, but the key thing is that the angle has to be measured in radians in order for this formula to work. Okay, so we're going to do a couple examples. We're going to find the length of the arc on a circle of radius r and central angle theta, and they give us that the radius is 3 feet and that the central angle is 5 pi over 6. Well, this angle is already in radians, so all we need to do is just multiply and then we're done. So the radius is 3, the central angle is 5 pi over 6. Just multiply those two together, 15 pi over 6. And you can reduce that down to 5 pi over 2. Or if you'd want to give your answer in decimals, it's 7.834. And the units for the arc length are the same as the units of the radius. So feet would be our units. For part B, if you look at the angle is given in degrees. So we need to convert that into radians. So again, to convert degrees to radians, we multiply by pi over 180. And if you simplify that down, you're going to have pi over 4. So that's the angle we want to use. So now to find our arc length, we're going to take the radius of 6 and multiply by our angle in radians. And so that would be 6 pi over 4, or you could reduce it down to 3 pi over 2, or you can give the answer as a decimal, which would be 4.712. And again, the units are whatever the units of the radius are, so inches. The main thing though is you gotta make sure that your angle is measured in radians to use this formula. Now we might go backwards and I might say find the angle. So here's the formula again. So if I want you to find the angle, you're going to have to put something in for the arc length and you're going to have to put something in for the radius. The arc length is this 31, the radius is 12, and I didn't give any units. So 31 equals 12 times theta. Divide 31 by 12 and you get 2.58. Now what happens a lot to people is they look at that angle up there and they think, that doesn't look like 2.5 degrees. Well, it's not degrees, it's radians. This whole formula is based on the angle being in radians. 2.58 radians is like 140 something, right? Let's see. 2.58 radians and multiply by pi, or 180 over pi. (147.82 degrees). But you just leave your answer in radians. The main thing I just want you to know is that when you get that theta, it is in radians. Okay, now we're going to move on to linear speed and angular speed. And the thing that makes these difficult is you think that there should be a formula, but there's really not. I mean, these look like formulas, but they're not. It's all in unit conversion. So you have to think about what units you want to end up with and convert until you get those units. So here's the units you want to end up with. For linear speed is how fast the particle is moving. And so it would be like inches per minute or feet per second, some unit of length over time. It's linear, so however you could measure linear things, you know, like inches or feet or meters. And then speed deals with time, so it's some unit of time over here. The other kind of speed we're going to look at is angular speed, and that's how fast the particle is rotating. So we're talking about rotating, which means we're going to be focusing on angles. So we've got an angle over time. So it's going to be radians per minute, or radians per second, or radians per hour, or radians per some time unit. So if you're doing a problem with linear speed, it's got to be like inches or feet, something like that, per time. So minutes or seconds, okay, or meters per second, something like those. These will always be radians because it's angular speed. So just think angular, angle, radian. Radians per second, maybe. Okay, so we're going to just do some problems. Okay, so little Johnny is cruising along on his tricycle, which has wheels of radius 10 inches. If the wheels are spinning at 20 RPM, that's rotations per minute. Find his angular speed. Okay, so angular speed, we want to end up with radians per minute in this problem because we were giving rotations per minute. So radians per minute, okay. Well, let's start with what we're giving. We're given 20 rotations per, you know, another word for rotations is revolutions. Okay, so you could say rotations per minute or you could say revolutions per minute. I'm going to use revolutions. 20 times around the circle. So 20 revolutions per 1 minute. And we are going to convert this into radians per minute. So we already have the minute part down. Now we need to get rid of revolutions and translate it into radians. Now, if it's on the top, it needs to go on the bottom. How many revolutions, or actually I should say, how many radians are there in one revolution? How many radians are in one revolution? How many radians are there in one time around the circle? 2 pi. See how the revolutions cancel? And then my units are radians per minute. So all I have to do is do 20 times 2 pi, which would be 40 pi. On the bottom, 1 times 1 is just 1. So 40 pi radians per minute would be the angular speed. If you want to write that as a decimal, it would be 125.664 radians per minute. You gotta always have your units on there. That should say minute. Okay, linear speed. Now we want to get it into feet per second. So we're going to have to convert a lot of things. We have to get minutes into seconds. We have to go from revolutions to feet. Okay, so let's always start with what we're given. 20 revolutions per 1 minute. Okay, now it might be easier for you to convert minutes to seconds right off the bat. So let's try that. So if minutes are on the bottom, then minutes are going to have to go on the top, and seconds will go on the bottom. So there are, okay, so in 1 minute, there are 60 seconds. So minutes are done. Okay, now we gotta convert revolutions into feet. Well, if revolutions were on top, revolutions have to go on the bottom. And we want to try and figure out how many feet there are in one revolution. But back up and look at our radius. Our radius is in inches. So maybe we should start by figuring out how many inches are in one revolution. How many inches are there in one revolution with a radius of 10 inches? One revolution would be this. What's that called when you go around the circle? Circumference. Circumference is 2 pi r. So in this case, the circumference would be 2 pi times 10. That would be how many inches there are in one revolution. 2 pi times 10 inches per revolution. So revolutions are gone. Now we need to get inches into feet. If inches are on the top, then inches go on the bottom. So there are 12 inches in 1 foot. So the inches go away now. So now our units are feet over seconds. So now what we need to do is just multiply straight across the top and straight across the bottom. So on the top, we've got 20 times 2 times 10 times pi. So on the top, we've got 1256.64, whoops. And on the bottom, we've got 60 times 12, 720. Okay, and divide those. And we get 1.745 feet per second. Okay? So it's all about unit conversions. Now, I'm going to have to start a second video. So now what you're going to do is you're going to watch part 2 of the video. So it'll be a separate video. And when you're done with that, it's only going to be like 1 or 2 more examples. When you're done with that, then start the homework. Okay?